Good morning, everybody. Hope you're doing great wherever you're watching from. It's August 8th, 2026, and right now there's a monster sitting in the East China Sea that has already battered Okinawa, shut down an international airport, injured people on the ground, and is now bearing straight down on one of the most economically important coastlines on the entire planet. This is Typhoon Dolphin, and if you have not been following this storm, you need to catch up right now because within the next 48 to 72 hours, this thing is going to make landfall somewhere between Shanghai and northern Fujian province, and it's carrying enough energy to be one of the most talked about weather events of the year. So here's what we're going to cover. First, I'm going to walk you through exactly where Dolphin is right now, how strong it is, and where it's projected to go. Then we're going to talk about what already happened in Okinawa, because this storm has already left a mark before even touching the mainland. After that, we're going into the meteorology, because I want you to actually understand why this storm blew up the way it did, what rapid intensification really means, and why forecasters are calling this track unusual. Then we'll get into what China is doing right now to prepare, because the scale of this response is honestly wild. After that, we'll zoom out into a global roundup, because while the Pacific is on fire, the Atlantic is doing something almost the exact opposite, and that contrast tells you a lot about the year we're in. And then we'll finish with the bigger picture, the stuff nobody's really connecting together, what this storm means for supply chains, insurance markets, and the broader pattern of 2026. So stick around, this is a lot to get through. And if you find this kind of breakdown useful, go ahead and hit that like button, drop a comment with where you're watching from, and subscribe so you don't miss the next update as this storm develops, because this situation is moving fast. Let's start with where things stand right now. As of the most recent advisories, Dolphin is sitting roughly 130 kilometers west of Kadena Air Base, which puts it just off the coast of Okinawa, and it's been tracking southwest at around 17 kilometers an hour. That might sound slow, and it is slow, but slow is actually the dangerous part here, because a slow-moving typhoon means more time sitting over the same stretch of ocean, more time dumping rain, and more time for coastal flooding and storm surge to build up before it even makes landfall. Current maximum sustained winds are being estimated around 165 kilometers an hour, roughly 90 knots, which puts it back into strong typhoon territory after a brief dip in intensity. And that's actually one of the more remarkable parts of this story. Dolphin didn't just weaken and fade out after pounding Japan's outer islands, it actually reintensified. It found warm water again, found a pocket of low wind shear, and it built itself back up right as it's approaching one of the most densely populated coastlines on Earth. Maximum significant wave heights out at sea are being reported around 12 meters, that's about 40 feet, which tells you the sheer amount of energy this system is still carrying even after everything it's already been through. Now here's the part that makes forecasters nervous, and this is something I really want you to understand instead of just skimming past. The steering pattern around Dolphin has been genuinely unusual. There's a subtropical ridge sitting over Honshu that's been the main thing pushing this storm westward, but that ridge has weakened just slightly. At the same time, a separate ridge extending out from mainland China has built in from the west, and it's been reinforcing that westward and southwestward push. What that combination does is it keeps Dolphin moving in a direction that isn't a clean, predictable line. Over the next 2 days, forecasters expect the storm to recurve, meaning it'll start bending back toward the north as that primary ridge over Japan rotates away to the southeast. And when a storm recurves like that right as it's approaching a coastline, the exact landfall point becomes a lot harder to pin down days in advance, which is exactly why you're seeing meteorologists in Beijing and Tokyo hedging their language, giving ranges instead of single points, because even a small shift in that ridge pattern moves the landfall zone by dozens of kilometers. So let's talk about what's already happened, because Dolphin has already made its presence felt. As the storm tracked close to northwestern Okinawa, it caused real damage even without a direct landfall on the main island. At least 5 people were injured, mostly elderly residents, several from falls, and a handful of homes suffered partial damage from the wind. Naha, the main airport serving Okinawa, was forced to shut down completely, grounding every flight in and out of the island for the duration of the worst weather. If you've ever been stuck in an airport during a storm delay, multiply that frustration by an entire island chain that depends heavily on air travel for both tourism and basic supply logistics, and you start to understand what a full airport closure actually costs a region like this. On top of that, U.S. military installations on Okinawa, including bases like Camp Foster, went into storm preparation posture days in advance. Commissaries saw people stocking up on food and water, flights were grounded, and personnel were bracing for what officials described as a potentially lengthy lockdown given how slow this storm has been moving. When you combine a slow-moving system with a heavily populated island that also happens to host a significant concentration of American military infrastructure, that's not just a weather story anymore, that's a logistics and readiness story too. Now let's get into the meteorology, because I think this is where the real story is, and it's the part most casual coverage skips right over. Dolphin's origin story actually goes back to late July, when it formed out of a tropical depression over the open waters of the Central Pacific. At that point, it was unremarkable, moving at a modest pace, nothing that stood out. But then it did something that meteorologists watch for very closely, and it's called rapid intensification. In simple terms, rapid intensification is when a tropical system's maximum sustained winds increase by a significant amount, typically defined as at least 30 knots within a 24-hour period. Dolphin blew past that standard. It went from a tropical storm to a full Category 5 super typhoon in roughly 2 days. 2 days. Think about how fast that actually is. That's the difference between a system that might knock down a few tree branches and a system capable of leveling structures. And it happened in less time than most people take to plan a weekend trip. So what actually causes rapid intensification like this? It comes down to two main ingredients, and both of them were sitting there, waiting for Dolphin like fuel on a fire. The first is sea surface temperature. Warm ocean water is basically the engine for a tropical cyclone, because as air passes over warm water, it picks up moisture and heat, rises, and that rising air is what drives the whole circulation. Dolphin passed over water sitting between roughly 29 and 30 degrees Celsius, which is on the warmer end of what you typically see, even in a tropical basin during peak season. The second ingredient is wind shear, and this one works in the opposite direction. Wind shear is the change in wind speed and direction at different altitudes, and high wind shear tends to rip a storm structure apart before it can organize. Low wind shear, on the other hand, lets a storm build a clean, symmetrical structure, and that's exactly what Dolphin found. Warm water plus minimal wind shear is basically the perfect recipe, and the storm took full advantage of it. At its peak in late July, Dolphin reached sustained winds of around 165 miles per hour, which is 270 kilometers an hour, officially making it a Category 5 equivalent system, and the fifth Category 5 tropical cyclone recorded globally in 2026. Now, to put that number in context, 2026 is actually running ahead of the pace set by 1997, which still holds the all-time record for global Category 5 cyclones in a single year with 12. We're not there yet, but the fact that we're already at 5, well before the year is even close to finished, tells you something about how active this basin has been. And if you look at satellite imagery from around that peak intensity period, meteorologists were pointing out something called mesovortices embedded in the storm's upper cloud structure, which are smaller rotating features within the larger eye wall that typically show up in extremely intense, well-organized systems. That's not something you see in a run-of-the-mill typhoon. That's a signature of a storm operating at close to its theoretical maximum potential given the environment it was in. After reaching that peak, Dolphin did what most storms eventually do. It started to weaken slightly as it moved over cooler water and picked up some dry air intrusion, dropping back down to a still very strong typhoon in the Category 1 to 2 range in terms of raw wind speed comparisons. But here's the twist, and this is the part I mentioned earlier that's been catching forecasters' attention. As it approached Okinawa and the Ryukyu Islands, it found another patch of favorable conditions and reintensified, climbing back up toward 165 kilometers an hour in sustained winds. A storm that reintensifies right before making a second run at land is genuinely one of the trickier scenarios for forecasters, because it means the models that were built off the storm's earlier weakening trend suddenly have to account for a system that's punching above its expected weight again. There's also something worth understanding about the overall track here, because Chinese meteorological officials have specifically flagged this as unusual. Dolphin formed all the way out near the international dateline, which means it has traveled an extraordinarily long distance across the Pacific before threatening to make landfall in China. Forecasters have noted it's genuinely rare for a storm that originated that far away, on that long of a track, to still be arriving at this level of intensity by the time it reaches the Chinese coast. Most systems that travel that kind of distance lose steam along the way, get disrupted by land interaction with the Philippines or Taiwan, or simply run out of warm water to feed on. Dolphin has managed to avoid most of those fates, threading a path that kept it over favorable water for an unusually long stretch of its lifespan. There's a number meteorologists use to measure just how much total energy a storm produces over its entire lifetime, called accumulated cyclone energy, and Dolphin's value on that scale has already crossed 43, which is an exceptionally high figure for a single system. To put that in perspective, that number accounts for both how strong the storm got and how long it sustained that strength. And a value that high tells you this wasn't a storm that spiked briefly and faded. It held on to major intensity across a long stretch of open ocean. That single storm's contribution has played a meaningful role in pushing the entire Western Pacific typhoon season well above its usual seasonal energy output for this point in the year. And when forecasters start talking about a season being ahead of pace, storms like Dolphin are exactly why. It's also worth understanding what actually happens inside a storm like this when it goes through these swings in intensity, because it isn't random. Very strong tropical cyclones often go through something called an eye wall replacement cycle, where the original inner eye wall, the ring of the most violent thunderstorms surrounding the calm eye, gets choked off and replaced by a new, larger eye wall forming further out. During that transition, the storm typically weakens slightly and its wind field actually expands, meaning the area of strong winds gets physically larger even as the peak wind speed drops a bit. Once that new eye wall fully takes over and contracts, the storm can reintensify, sometimes ending up with an even larger overall wind field than it had before. That process lines up almost exactly with what we've seen out of Dolphin, the peak, the slight weakening, and then the reintensification as it approached Okinawa. It's a natural part of how the most powerful storms evolve. But it also makes forecasting exact intensity at landfall genuinely difficult, because predicting precisely when and how an eye wall replacement cycle will play out is still one of the harder problems in tropical meteorology. Now let's talk about China, because the scale of preparation happening along the eastern coast right now is honestly massive, and it gives you a sense of just how seriously this storm is being taken. The latest guidance from China's National Meteorological Center puts landfall somewhere along the coast between Zhoushan in Zhejiang province and Fuding in Fujian province, expected sometime between late Sunday and early Monday. At landfall, winds near the center are expected to be in the range of 38 to 45 meters per second, which converts to roughly 135 to 160 kilometers an hour, putting it solidly in strong typhoon to severe typhoon territory, even after crossing all that open water. And rainfall is where this really gets serious. Some areas of eastern Zhejiang are forecast to receive more than 600 millimeters of rain, that's about 23.5 inches, which is an amount that can overwhelm drainage systems, trigger landslides in hilly terrain, and push rivers well past their warning levels in a very short window. China's Ministry of Water Resources has already put out guidance calling for preparation based on worst-case scenarios, specifically naming the Pearl River Basin, the Yangtze River Basin, the Yellow River Basin, and the Taihu Lake region as areas facing significant risk of rivers rising sharply. They're also watching parts of Yunnan, Zhejiang, Fujian, and northeastern China closely, because smaller and medium-sized rivers in the heaviest rain zones could rise above warning thresholds, and mountain torrents, which are essentially flash floods that come roaring down hillsides and through narrow valleys, are a real concern in some of these regions. Authorities have said the priorities here are straightforward but critical: preventing casualties, preventing dam failures, preventing breaches in major dikes, and protecting critical infrastructure. That's the kind of language you use when you're not just preparing for wind damage, you're preparing for the possibility of catastrophic flooding. On the ground, the response has been enormous. Zhejiang province raised its coastal typhoon alert to the highest level available. Port operations along the coast have been completely halted. More than 160 passenger ferry routes have been suspended. Construction projects have been paused. Fishermen have been ordered to evacuate their vessels and bring them into safe harbor. And if you've seen any of the footage coming out of coastal fishing towns like Wenling and Taizhou over the past few days, you'll have seen harbors absolutely packed wall to wall with fishing boats that have all come in early to ride out the storm. China has also been deploying drones and AI-assisted monitoring systems to patrol coastal waters and track the storm's approach in real time, which gives you a sense of just how much this kind of disaster response has modernized. This isn't just sandbags and evacuation orders anymore. It's a coordinated effort using aerial surveillance and predictive modeling to get ahead of exactly where the worst impacts are going to land. And here's something that really puts the scale of this in perspective. Some reporting has described the area affected by this storm system as roughly 1,230 times the size of Hong Kong. Now, take that with a grain of salt as a rough estimate rather than a precise scientific figure. But even as a general sense of scale, it tells you this isn't a localized weather event. This is a system large enough to influence weather patterns across a huge stretch of the Chinese mainland, not just the immediate coastal strip where landfall occurs. What happens after landfall matters just as much as the landfall itself. Forecasters are watching two main scenarios play out. In one, Dolphin makes landfall, moves westward, gradually weakens, and then curves northward, bringing strong winds and heavy rainfall to Zhejiang, Shanghai, Jiangxi, and Anhui before losing most of its punch. In the other scenario, the storm tracks more directly northward along the coast, staying closer to the water longer, potentially brushing up along Jiangsu and Shanghai before reaching toward the Shandong Peninsula sometime around August 10th or 11th. That second scenario would spread heavy rainfall across a wider stretch of eastern and even northern China. And there's a third wrinkle worth mentioning, because Chinese meteorologists have noted that after landfall, Dolphin's remnants could combine with an incoming pocket of cold air, and that interaction has the potential to trigger a secondary round of heavy rainfall across parts of northern and northeastern China around the 12th through the 14th of August. So this isn't a one-and-done event. Even after the storm technically makes landfall and starts to weaken, the moisture and energy it's carrying could keep causing problems for the better part of a week. This is actually the fourth typhoon to hit China so far this summer, which tells you this has been an unusually active season for the region, and Dolphin is being described by Chinese officials as the 13th named typhoon of 2026 overall in that basin. When you stack up a storm this intense on top of 3 previous landfalls in the same summer, you start to understand why infrastructure in this region is already under strain heading into this event. Because reservoirs, drainage systems, and dikes that absorb the impact of earlier storms this season now have to handle another major system without a full recovery window in between. And it isn't just China watching this closely. Taiwan sits close enough to Dolphin's track that waters east of the island and through the Bashi Channel have been placed under strong wind and high wave warnings, even without a direct landfall threat there. Shipping lanes running through that corridor, which is one of the busiest maritime choke points in the world for container traffic moving between Southeast Asia and Northeast Asia, have already seen vessels adjusting course or delaying departure to avoid the roughest seas. The southern Yellow Sea and the waters around the Yangtze River estuary and Hangzhou Bay have also been placed under strong wind advisories well ahead of the storm's actual arrival, which shows you how far out the influence of a system this size extends before the center itself ever comes close to the coast. Let's shift gears for a second and go into the global roundup, because there's an interesting contrast happening right now that a lot of people aren't connecting. While the Western Pacific has been an absolute factory for intense typhoons this year, with Dolphin being just the latest in a string of powerful systems, the Atlantic hurricane season on the other side of the planet has been almost eerily quiet. As of the first week of August, the Atlantic has only produced 2 named storms, Tropical Storm Arthur and Tropical Storm Bertha, and neither one reached hurricane strength. For comparison, the average date for the 3rd named storm of a typical Atlantic season has already come and gone, meaning the basin is running noticeably behind its usual pace. Forecasters at both NOAA and Colorado State University have pointed to the same underlying cause, a strong developing El Niño pattern that's driving unusually high levels of vertical wind shear across the tropical Atlantic and Caribbean. Remember what we talked about earlier with Dolphin, how low wind shear let it explode in intensity. Well, the Atlantic right now is dealing with the exact opposite condition, and that shear is essentially shredding storm systems before they ever get the chance to organize. NOAA's most recent outlook actually revised its seasonal forecast downward, now projecting somewhere between 7 and 13 named storms for the entire Atlantic season, with as few as 0 to 2 reaching major hurricane status. Colorado State University's forecast lines up closely, calling for around 9 named storms and 4 hurricanes, with only 1 expected to reach Category 3 or higher. If that forecast holds, it would mark one of the quietest Atlantic hurricane seasons in more than a decade, the fewest hurricanes since the middle of the last decade, and the fewest major hurricanes in well over 10 years. To put that in perspective, an average Atlantic season produces around 14 named storms, 7 hurricanes, and 3 major hurricanes. So even the upper end of this year's projections is running noticeably below what's typically expected. Forecasters have also pointed out that the probability of a major hurricane making landfall along the continental United States coastline this year is sitting well below the historical average, which is obviously good news for coastal communities from Texas to the Carolinas, even though officials are always quick to remind people that it only takes one storm making landfall in the wrong place to make a season feel active, regardless of how the overall numbers shake out. So here's the bigger pattern we're sitting with for a second. The same broad atmospheric setup driving El Niño that's suppressing storm formation in the Atlantic is part of a global circulation pattern that can actually enhance conditions favorable for storm development in parts of the Pacific. It's not a one-to-one direct cause and effect. The Western Pacific has its own set of drivers, but when you zoom out globally, you're watching one ocean basin get unusually quiet while another one produces its 5th Category 5 cyclone of the year. And that kind of split is exactly the sort of thing climate researchers pay close attention to when they're trying to understand how these large-scale patterns redistribute storm activity around the planet rather than simply turning the volume up or down everywhere at once. Now let's zoom all the way out and talk about the bigger picture here, because there's more going on with this storm than just wind speed and rainfall totals. The coastline Dolphin is targeting isn't just any stretch of coast. Shanghai and the surrounding Yangtze River Delta region represent one of the most economically significant zones on the planet. This area includes some of the busiest ports in the world, massive manufacturing hubs, and a huge concentration of both domestic and international shipping traffic. When you halt port operations and suspend over 160 ferry routes, you're not just inconveniencing local travelers, you're creating ripple effects through global shipping schedules. Container ships that were due to load or unload during this window either have to wait it out at anchor or reroute, and depending on how long the disruption lasts, that can cascade into delays that show up weeks later on store shelves and in supply chains halfway around the world. This is the kind of storm that doesn't just make headlines for a day or two, it shows up later in quarterly shipping reports and insurance claims data. Speaking of insurance, this is worth thinking about too. A storm capable of dumping over 600 millimeters of rain in a matter of days across a densely built, low-lying coastal region creates exactly the conditions that drive major flood damage claims. Urban flooding in a place like Shanghai, where you've got enormous amounts of paved surface area and a river delta system that's already working hard to manage normal seasonal rainfall, can escalate quickly when you add a slow-moving typhoon on top of it. And remember, this is the fourth typhoon of the summer hitting China, meaning drainage infrastructure and reservoir capacity across the region may already be running closer to their limits than they would be at the start of a normal season. That compounding effect, storm after storm without full recovery time in between, is one of the most underappreciated risks in any active typhoon season. Because the danger isn't always about any single storm being catastrophic on its own. It's about the cumulative strain building up across a region over the course of weeks. There's also a broader climate conversation embedded in all of this that's worth touching on honestly and carefully. Rapid intensification events, like the one Dolphin went through when it jumped from tropical storm to Category 5 strength in roughly 2 days, have been happening with increasing frequency in recent years across multiple ocean basins. Warmer ocean surface temperatures provide more available energy for storms to tap into, and when a storm finds a pocket of low wind shear on top of that warm water, the result can be an extremely fast and sometimes hard to predict escalation in intensity. This doesn't mean every storm is going to behave this way, and forecasters are always careful not to overstate any single event as proof of a larger trend. But when you're watching 2026 track ahead of the pace of 1997, still the record holder for global Category 5 storms in a single year, that's the kind of data point that keeps climate scientists and disaster planners paying very close attention to how these patterns are shifting over time. There's one more piece of the bigger picture worth sitting with before we get to what people on the ground should actually be watching for, and it's the question of how a region recovers when disaster response has to happen back to back to back within the same season. Every time a coastal province activates its highest level alert, halts port operations, suspends ferry routes, and evacuates fishing fleets, that's an enormous logistical and economic undertaking, even before a single drop of rain falls or a single gust of wind reaches shore. Doing that once in a summer is disruptive. Doing it for a fourth time in the same season, with reservoirs and rivers still carrying elevated water levels from earlier storms, starts to test the actual limits of a region's flood control infrastructure rather than just its emergency response playbook. That's part of why officials have been so explicit about preparing for worst-case scenarios this time around, rather than assuming the system can absorb another direct hit the same way it absorbed the previous 3. So what should people actually be watching for over the next few days if you're anywhere near this storm's path, or if you've got family, friends, or business interests in the region? First, keep an eye on official guidance from the Japan Meteorological Agency and China's National Meteorological Center, rather than relying on secondhand social media posts, because as we talked about earlier, the exact landfall point is still shifting within a fairly wide range, and official sources are updating that in near real time. Second, if you're in one of the affected coastal provinces, follow evacuation guidance seriously, especially in low-lying areas and anywhere near rivers that are already forecast to rise above warning levels. Flash flooding and mountain torrents tend to be far more dangerous than the wind itself in storms like this, and they can develop with very little warning once heavy rain starts falling over already saturated ground. Third, expect disruptions well beyond the immediate landfall window. Between the initial impact, the potential for the storm to linger inland for 2 to 3 days afterward, and the chance of a secondary rainfall event when the remnants interact with incoming cold air around the 12th through 14th, this is realistically a multi-stage event stretching out over more than a week. Fourth, if you're tracking this for business or travel reasons rather than personal safety, build in extra buffer time on anything routed through Shanghai, Zhejiang, or Fujian over the coming 10 days, because port and ferry disruptions on this scale tend to take longer to fully clear than the storm itself takes to pass through, simply due to the backlog of vessels and cargo that builds up during the shutdown window. And honestly, this is exactly the kind of story that's worth checking back in on, because storms like this rarely play out exactly the way the forecast maps show on day 1. The track can shift, the intensity can change, and the actual impacts on the ground often look different from what the models predicted 72 hours out. So if you want to stay on top of how this develops, make sure you're subscribed So you catch the follow-up. As new advisories come in, drop a comment letting me know if you or anyone you know is in the path of this storm, and share this with anyone you think needs to see it. Because the more people who understand what's actually happening here instead of just seeing scary headlines, the better prepared everyone ends up being. At the end of the day, Typhoon Dolphin is a genuinely remarkable storm, not just because of how strong it got, but because of the distance it traveled to get there, the way it reintensified right before its second act, and the sheer scale of the response it's triggering across one of the most important economic corridors on the planet. Whether it ends up recurving north along the coast or plowing further inland before weakening, the next few days are going to tell us a lot, and we'll be watching closely as those updates come in. Stay safe out there if you're anywhere near the system, and we'll be back with the next update as soon as there's more to report.